image processing in Python is not that complicated, but it is sort of useful to understand images and image formats, how they work and how those images are composed or how those images are represented in the computer's data. Because images, like all of our data on the computer, are just broken down into numbers. That's the way the computer sees them. The computer doesn't see a picture of a flower or a dog or whatever. It sees numbers. And those numbers are then interpreted by the computer to give us a visual representation. And so understanding how those numbers work is kind of important. So when we're looking at an image is always composed of pixels. And we're not as aware of the pixels nowadays because the resolution of our images is so high. The resolution of our screens, the resolution of our phones used to be, and I'm going to, forgive me, I'm going to sound like an old guy here, but it used to be that pixels were readily apparent on the screen because the number of pixels in a screen wasn't very many. And so you would see them. It was very plain to see, and the number of colors on a screen was not very many. I mean, in the 1980s, when I started programming BASIC on a Commodore 64, there were literally like 64 colors, I think, maybe less on the screen, and the number of pixels on the screen was like 400 wide. Okay, now we're looking at screens in 4K that have thousands and thousands of pixels on a screen, or just the width of the screen is multiple thousands of pixels. So the width times the height is even greater, and so we're not as aware of the individual pixels maybe as we used to be. But if you zoom in on literally any image, if you zoom in enough, you will end up looking at something like this. So if I take this section of this strawberry, and I actually did this, this is that exact section of that exact picture, and I zoom in on it, what you will see is pixels. And the raw image data is usually represented by each pixel having either 3 or 4 numbers associated with it. Now, often those numbers are not represented in digits, as you can see. A lot of times we see them in hexadecimal code, which we'll get into in a little bit. But the numbers, if there's 3 numbers, they represent the amount of red, the amount of green, and the amount of blue in each pixel. Each number is between 0 and 255. And if there's a 4th number, it is usually represented as the alpha channel, and that's a newer thing. It is RGBA. If you see those letters, that's what that means. Alpha refers to how transparent that image is. So if you have an image on top of another image, then the transparency of the pixels allows you to see maybe whatever image or whatever's behind the original image. So we've become more advanced in terms of viewing pictures as layers on a screen. But for example, this pixel right here has 68 red, 41 green, and 26 blue. And that's what makes that color. That's why we have about 64 million colors, because it's 256 times 256 times 256. Okay? So that's what gives us so many different color possibilities. You can see this red pixel here. Obviously, it's got way more red in it, green and blue. What happens if you say 255, 255, 255? You get white. 0, 0, 0 is black. So as you play around with colors and you start thinking about colors in terms of those 3 values, you'll start to get a sense of how those things work. And on my website, I actually created a game, because I also teach web design, and we use hexadecimal code in web design. So I created this game that forces people to or allows people, I guess, to learn colors by moving this slider, and you can see all of the different colors that you can create. And, I have to provide some pressure, but you try and match the color on the left with the color on the right, and it gives you the hexadecimal code. Each set of 2 characters here, 0D, F179, those represent red, green, and blue. So hexadecimal code, we don't know yet, but you can also see the color values right here on the right. So when we do colors, you'll get a sense of how that works. And as you start to think about user interfaces that are no longer just text-based user interfaces where you're doing buttons and backgrounds and images and things, the colors all of a sudden become a little more important to you.